Hello viewers, Alan here. Welcome to my workshop. In this video I continue my project of making this Webster engine. I replaced that horrible cast iron attempt at a flywheel with a 4140 steel flywheel. I sort out the friction in the cylinder with a diamond lapping process and make my first stab at the rocker arm. I've put links to the previous episodes in the remarks, but if you haven't already subscribed, you might like to consider doing that so you can catch up with the next episodes when they come through. Anyway, let's dive in and see how I made this progress. So I've got a bit of 100 diameter 4140 loaded up here to make a flywheel from, a flywheel Mark II. Hopefully I have a bit better luck machining this material than I did that awful weight. Anyway, I've just given it a quick roughing face off and I'll clean it up again with a better tool, hopefully. It's not the best facing operation I made. It's pretty good. The issue I think is just simply the difference in feet per minute here to here. Anyway, I've got more machining to do here, so I think this will get sorted out. Okay, so I think the next thing I'm going to do is start on the diameter a little bit. The drawing calls out for the outside diameter of this flywheel to be 95.25. So I'll start off by getting the DRO calibrated, and we'll do a 1mm depth of cut and see how close we finish up at 98 for our calibration run. Well, I'm not going to complain about that surface finish. Let's see what the diameter finished up at. Get rid of some of this stuff too. This steel wool. Right. So we're shooting for 98. 97.97. That's pretty darn good, isn't it? The next move is to cut this face back 4.76 to expose a centre stub about 16mm in diameter. I think we'll take a 1mm depth of cut to start with and see how that looks. See what the machine thinks of that. These stringy chips are a pain. Sitting on 16.34 there, so that gives me plenty of clean up scope. Happy with that. Well, that turned pretty nicely. Pretty much a mirror finish there. That was 0.2. Anyway, I'll be doing finishing pass on this later. I've just got to make sure I keep it over a useful amount to finish with, so that's looking good. So I think we're on our final pass here. That's bloody typical, isn't it? I didn't have any trouble with that stringy swarf getting in the way on the second to last cut. But on the last one, where the appearance mattered, that's when it decided to jump up. Now well, such is life. Actually, I suppose I could try to take one more cut to at least be nice for the thickness of the rim. So we'll go in with basically the smallest cut I can manage. So we'll go about 0.04, see if that's just enough to clean that up. Well, that's a lot nicer. Happy with that. So that was at 4.78 instead of 4.76, which I don't think will matter at all in the scheme of things. Right, now I don't need to do anything more with that at the moment because I'll be cleaning the outside diameter up afterwards. Alright, well let's see if we can start hollowing this out. I haven't tried to do one quite like this before. It's a bit awkward because you're trying to cut to that outer diameter and you need one tool geometry and the opposite geometry going the other way. But I'm sure we'll find a way, just sort of doing fits and starts, I expect. So I'm working on bringing the inside diameter of the rim to size now, using boring bars and other things. It's pretty awkward, and I don't know any way to get a continuous sort of cut across there. Anyway, we'll press on. Well, I was thinking about leaving the final cut to when I was doing cleanups later, but this is such an awkward bloody thing to work on. I think I'll try and get it now. Okay, well, I'm going to have a go at running a cutter across that back face. This is something I've ground up specially. We'll see if it's any good. Well, it's not a Rolls-Royce surface finish, but it is all at the same level all the way across. That might polish up quite well, actually. We'll see. So I've done a bit more of a clean-up on this side, a bit of chamfering, light chamfering on the corners, and shown it a bit more love with the emery and Scotch-Brite, and I'm quite happy with the way that's turned out. So, time to part this lot off, and I'm a bit nervous about that. This is far and away the biggest parting operation I've tried to do, so this is 100 diameter. We've got to go quite a long way into it. And I agonised over what width of bar to use. I've got two 3 and 4 millimetre wide ones. This is the 3 millimetre one, but I'm wondering whether I should have gone with the 4 millimetre one, or maybe start off with the 4 and some way in switch over to the 3. Actually, that might be a better strategy. Perhaps I'll do that. Righto, here we go then. That might be a bit fast. Well, it seems to be cutting all right now, but this can be a very slow process, so I'm going to stop the recording here. So I think we must be getting pretty close now, because we're in at 45. Switching over to the 3 millimetre blade made a big difference. All right, let's see if we can bring this baby home. There we are, safe and sound. And safe and sound was not a foregone conclusion. Might as well face this guy off before he goes back into the scrap bin or stock bin, whichever you want to call it. No, that's good enough for the offcuts pile. So I'm getting ready to machine the second side of the flywheel now, and my original plan had been to use the 4-jaw chuck, but these 10-inch chucks are not light, and it's not a 30-second job to switch them over. So I thought I'd just put it in the, turn it around in the 3-jaw and check the run out and see what we got. To see whether it was actually worth the effort. I think you're seeing there that the run out is, well, I'm not even sure it's 0.02. Looks like it's less than 0.02 to me. Certainly less than 1/1000th of an inch anyway. And so I can't be bothered putting in a 4-jaw to try to get from 1/1000th to 1/2 It's just not that important in this situation. So we'll press on like this. And be thankful for the quality of the Bison chuck, because it's outstanding, isn't it? The 3-jaw self-centering can do this sort of operation to within 1/1000th of an inch. Okay, so I've got one more pass to do now to bring the centre hub to length. So this will be about a 0.2, just under 0.2 depth of cut. The last one, as you can see, produced a fantastic finish because I didn't get any bird's nesting action that was interfering with it. But it remains to be seen whether I'll be that lucky this time. Fingers crossed. Yeah, pretty much. So let's see if I've finished up on size. 23.82 is what we were shooting for. I don't know whether you'll be able to see this, but got a bit lucky there. So that'll become the face of the hub, and I've got to take another 4.76 off to bring the width of the rim down. So as you can see, I've made some good progress with the second side. The only real machining left now is a counter bore here, 12.7 diameter and 4.76 deep, and that takes a mounting spigot on the back of the rocker shaft, I suppose you'd call it. It's not that critical because you make a mating piece to go into it. But anyway, we're aiming for 12.7 diameter, 4.76 deep. So we're on 12.351. Well, I'll take that. I've gone ever so slightly over. For a final check, there's a 1/2 inch dowel pin. It's a pretty snug fit. So I think we can say that we're on size. So I've just got a couple of bits of chamfering and a final clean up to do. So I've found that the surface finish inside the bore here, whilst it feels pretty good to my finger, isn't in fact smooth enough. When I put the piston in there and the conrod put a bit of side load on the piston, there was too much friction with the piston dragging in the bore. So I've decided I need to do a process called diamond lapping. Never done it before, but thankfully others have, and in particular one Mark Presling, who's put up a video explaining how he did pretty much exactly this on one of his engines. So I'll put a link to that in the description, and shout out to him and thank him for sharing. Anyway, the basic idea is to have a solid piece of soft material, or relatively soft material, in this case it can be aluminium. Make it a close fit inside the bore, and this is a very close fit, has to be lined up to fit. and then basically cover this with the diamond paste and rotate the two bags and forwards together. Now of course I need to do a bit more work on this. I've just turned the OD to be correct and put a hole through the middle, but what I also need to do now is another hole which is parallel to the central one but off to one side, and that'll create a weak spot on the periphery, near the periphery, and that becomes a hinge. Then the last bit is to slot it, slot that way, cut it through, and then put a couple of screws in so I can adjust the diameter. Then I can expand it as the paste starts to do its magic. Hopefully that will become clear as we get started. Right, so I'm all set to drill my hole here. I'm using a 5/32 of an inch drill for creating the hinge part of this. That's about 4mm. Now I've got to go really deep here. It's about 70mm, which is a lot for a drill this size. And I'll have to switch over to using this long series drill. But we'll get started with this one first, and there's going to be a lot of pecking, so I'll bring you, well, you see me get started, then I'll bring you back towards the end. I think I'll go pretty fast too because it's aluminium, a small drill. We go at 2000 RPM. Oh, there we go. Now, I'm not sure when that went out of focus, but anyway, we've come out the bottom. Well, that seemed to turn out quite well. So considering that hole was nearly 80mm long, in fact it was 80mm long, I reckon that's pretty good. This is the setup I'm going to use to drill and tap for two jacking screws to increase the diameter of the lap as it wears the bore. So I'll put a precision ground pin in that 5/32 hole, and by a bit of simple maths, if I put a 9mm spacer between the underside of that and the surface that this thing's sitting on, then I'll be pretty close, that axis will be pretty close to parallel, and obviously that these holes will be perpendicular to that. Start the drilling tapping process off by using a slot drill to give me some flat bottom pockets to work from. Alright, I think we're pretty much there now. Drill some holes. Right, let's get tapping. Be careful I don't go too far here because these are blind holes and not very deep. So I didn't have any 4mm grub screws, 6mm long, so I had to make a couple. So I just cut the heads off a couple of screws. Right, so he's 6.64, got to take 0.6 off. Right, so having shortened the screw in the lathe, now we've got to cut the slot in the head. I'm not going to worry too much about getting it exactly in the centre. These are single-use screws. Something like that's probably pretty good. Oh, stay in the slot. Right, well, the screwdriver's fitting nicely in the slot now. I think you'll be able to see that that's the case. So that should get the job done. So hopefully my grub screw will fit in there. Yeah, I think by the time I put the slot in, that'll give the screw just a bit more room to move. But I have to shorten the screw, so be it. But I think they'll be alright. Okay, so I'm ready to slit the lap, the whole length of this side. And I have to say I'm a bit nervous about that. The most appropriate cutter I've got has got fairly big teeth. And I'm just a bit dubious about just how much grip the vice has got on this thing. I don't want the cutter ripping it out of the vice. Anyway, what speed are we on? About 100 RPM, something like that. Well, that's probably about right. It's not a very big cutter and it is aluminium. So I think it's time to gird the loins and hope for the best. feed it by hand until my confidence level comes up. Yeah, well, that's good, isn't it? That's certainly done the job. Okay, so I finished making this lap. Got the screws sorted out. That's the obviously the long saw cut. Then at 120 degrees, so I'm not sure how well you better see that. There's a scribe line and one the 120 the other way. My hope is that that big groove and these scribe lines will hold a little bit of the grinding paste, the lapping paste, and help spread it around. We'll see if that's the way it turns out. But this is held in place with a couple of collars, and perhaps you can see this collar's got that's the end of a roll pin which runs back into the secondary hole in this thing. The whole lot sits on an 8mm rod and can float around on that, which is sort of as described by Mark Presling in his video. So hopefully that's going to work for me. And while we're here, you can have a bit of a better look at the new flywheel, which seemed to turn out alright. It's got a lot of angular momentum, I'm going to tell you that. But anyway, I'm quite happy with the way that turned out. So, it's time to go over to the lathe with these two pieces and see if we can make some magic happen in the bore. And I've got the floating lap on its arbor mounted in the chuck, and I've only got this here as some sort of a wrist rest. I don't know whether that's going to be useful or not. I've got to say I'm a little bit nervous about this, never done this before, but there's a few things about this job I've never done before, so let's get into it. So just as a refresher, there's a look at the inside finish on the piece. I want to get a bit better than that. So to give myself a bit of a benchmark, I've just taken 5 readings of the internal diameter, the bore diameter, and averaged them out at 22.203. So cutting a long story short, the screws that I had there, the ones that I laboriously made, didn't in fact clear the bottom of the hole. Reason being that when I put the tap down through there wasn't enough run out into that narrow slot to thread the holes right to the bottom. So to fix the problem, I located some 4mm grub screws and dropped a 3mm ball bearing down the hole. So now if I put a piece of shim in there and do this up, I can nip the thing. So I'll undo this a whole turn from there. Repeat on this side. Now I think the heads of the screws are below the edge, yes. But there's still no clamping pressure. Right, so I think we've got a workable situation now. Right, had a bit of progress. It looks a little bit battle scarred, but we've got some movement on here now. So I'll charge the thing up with some more goop and see if we can make some progress. See how we go with that. So it's time for what I hope will be the final check measure. See what we got. So we're sitting on 22.213. It's very awkward, sorry about that, but anyway, 22.213, which is 0.01 more than we started with. So the lapping process has taken nearly half a thou out of the bore, but I reckon that's going to be good enough. And the piston now seems to go into the bore quite nicely. So I'm going to call lapping done. I can't say I'm sad that I've finished. It's a messy business, and trying to keep everything clean is a problem. Anyway, lapping's finished. Well, that's looking pretty shiny in there now. I don't know whether you'd call that a mirror finish, but it's pretty shiny, and the piston slides in there quite nicely. So, with the new flywheel and the piston running smoothly in the newly lapped bore, that finishes the current round of remediation work, and I can move on to making something new. And I think my next target is going to be the rocker arm. The rocker arm sits in here. There's a pivot point there, and there'll be some cam action up this end off the flywheel, which gets translated to up and downitude here to open and close valves. The thing was originally specified, like all the rest of the bits, in imperial dimensions, so it was originally, I think, set to be 5/16 high, or 5/16 that way, and a bit under a quarter that way. Well, in my world that translates to just under 8 millimeters. It's from here to here. Actually, it's a bit deceptive. It isn't that dimension, it's from there to there, which is about 8 millimeters. And then this bit is a bit less, at 5.5 or so. So, I've got a piece of old key stock here. I think this must have been left over from one of Noah's constructions. But anyway, it's an appropriate size, because whilst it is in fact an imperial size, 5/16 by a quarter, it's pretty much exactly the right size for this piece. So I'll just be able to basically clean it up a bit on the faces, which don't get milled out, and then for the rest of it, it's pretty much a milling exercise. So better get to it. So I've got my piece of stock mounted in the vise. I've cut it to length, and it's time to face two sides so that I can achieve the 5.56 dimension. It should be a pretty straightforward milling operation, as long as I don't mess anything up. Well, that cutter's leaving a pretty good finish. Happy with that. Okay, so now getting set up to do the second side to bring it to the required thickness. A good surface finish again. Once done that, I finished up on size, and the ends are within 0.02 of each other, which is more than good enough for this. So I've got to mount it now and start doing the features on these other pair of edges. So back in the vise. Okay, so I've made that first cut across here and brought this height down to the top surface of the square block on the end. So now I've got to take the next piece out to expose the top of that square block. Right, I checked the depth at both ends of that trench. It looks like the trench is parallel to the surfaces, so we'll press on. Take another 0.5 depth of cut. 0.1045 up that end. What do we got up the other end? Oh, I've got the same. 0.1045. Oh, well, I'm happy with that. I mean, that's obviously what we'd hoped to get. But I was a bit concerned about stress being relieved from this piece and it's starting to curl or otherwise stick around. But anyway, so we've got the same depth at each end at the moment. The removal of that metal has released some stress in the material, and it's curled a little bit. I'll get a feeler gauge on it and see what the curl is. It looks like it's several thousandths of an inch, so I have to decide whether that's going to bother me, and if it is, what I can do about it. So let's go and get a feeler gauge in here and see how much it's moved. So the feeler gauge is showing me it's about 3 thousandths or 0.08, and I think given the way this thing is intended to work, I'm just not going to worry about it. I suppose if necessary I could apply some bit of a bend to it to try and straighten it up, but I think for the way it's intended to work, I don't think 3 thousandths of an inch movement is going to be an issue, so I'm going to ignore it. Okay, so I'm ready to start cutting the material off the other edge of this thing, and in putting this in the vise I checked again with the feeler gauge and the straight edge, and actually tapped this end down a little bit to take some of the curl out. I don't know whether this clamping arrangement is strong enough to hold it against the vibration and pressure of milling, but it might be. I've got nothing to lose by trying anyway. So it's an issue up to about this point here. After that there's no drama. So I think what I'll do is start at this end and go that way, and check from time to time, see what it's looking like. But I only, from here to there, I only have to do 1.59. I don't have to go deep, so that's 3.5 passes basically. Alright, enough talking, better get started on it. Yet another clean up and see what we've got. And we'll see if we finished up with that still on 0 to start with. Yeah, well it's still on 0.02 anyway, so that's good. So now we have to do the other bit of the dog leg. Right, so I've had a good look at this, and the clamping setup I've got at the moment won't allow me to get the full depth I need over here. So because I'll then have to reclamp it with even less in the vise, I'm going to do this in 2 parts. So I'll do the first half, which is 1.6 millimeters, reposition, and then for the next to take it out to 3.18. Bit of messing around, but I think that's my best option. Right, so this is going to be the last cut with this setup, and then we've got to reposition in the vise. Right, another big clean-up. So I've cleaned this piece up and checked it, and it's curved down like that as well, with the stress relief from taking that material out. So I'm just going to put a bit of a squeeze on it here and see if I can get it back to being somewhere near straight. I might have to repeat this again afterwards. I don't think this is a problem because this isn't in contact with anything that depends on it being dead flat. Anyway, we'll give it a bit of a squeeze and then check again afterwards. Well, you can see it's been pushed down here, but it's bound to spring back, so it's a bit of a guessing game how much to do it. Anyway, I'll release it and we'll see what we've achieved. So in case that isn't enough, I've just checked with a feeler gauge, it's about 16 thou fits under there. So if I, when I pull it apart and check it, if I need to do more, at least I know what the starting point is. I don't know how well you'll be able to see this, but I overshot ever so slightly. But I can't get a feeler gauge in the overshoot, so I'm calling it good. I'm going to press on. Well, actually that turned out alright. It didn't in fact wander off. I was a bit surprised, but it finished up quite straight. So happy about that. So all I've got left to do is drill a couple of holes. Okay, so I've finished the rocker arm, or at least my first stab at the rocker arm. It's just sitting there on a standard bolt with an ordinary bolt put in there. That'll have to be replaced with a custom made thing to be a tappet, and this will be replaced with a shoulder bolt. And there'll be in due course some cam arrangement on the back of the flywheel that causes the rocker arm to go up and down. It remains to be seen whether I've made a problem for myself by making this side frame 10mm thick instead of 8. It changes some of the spacings, but it's what I had, so I have to try and work out a way of making it fit, fiddling around with spacers and other things. Okay, well, I'm happy with the progress I made since I last put a video together. I don't know how this rocker arm is going to work out. I touched on that because I played around with some of the dimensions. I may finish up having to custom make bits and pieces, or maybe even make the rocker arm a different shape. But sorting that out is for the next episode. I hope you can join me. In any case, thanks for watching this one. Cheers.